All right, just seeing if this is working. Streaming. Twitter's not working. 1 second. Okay. Testing. How's the sound? Well, at least we're on to YouTube. Twitch. You on LinkedIn? Okay. Are we on LinkedIn? Maybe. Okay. All right. Well, that's probably good enough. Okay. Well, we'll go to this. Go. All right. Whoops. Just make sure we're still going. All right. All right, that seems fine. All right, so I'll just run what we're going to do real quick, what we're working on. Okay. All right, so we're working on an AI system to do basically an AI agent to do tasks. And by tasks, I mean like various things that you would do on your computer. So I'm calling, I gotta get a name for the system, but basically it's an autonomous system that should do tasks, and we're working on building out the system. So we need to get the training data and build the model. So the basic idea is we have we're going to start by training it to more or less copy tasks. So I have a system that captures all of your mouse clicks, mouse moves, and keyboard input. So it's basically the data. It's all the basically all the input events. And I tokenize these. So just an example, just so you can see what these look like. It's just a screenshot that's taken every 10th of a second, basically, and then along with that screenshot is stuff like mouse moves. So it'll be mouse moves, keyboard input, or I think I call it type. A lot of mouse moves, key presses, mouse moves, and mouse clicks. So that's basically what all the input. Key press, mouse move, and mouse click. So that's all our data. And we're going to pipe that data. We're going to use this data. We're going to tokenize it. You can see how I'm tokenizing it in my data loader. So basically, we turn it into tokens. That's just like a string or a sentence, basically. We tokenize the input, and then we use a sequence-to-sequence model to, well, I say sequence, we're going to build the model that predicts what the next user action is going to be based on the past actions and the past screenshots. So what they're up to, basically. So we take all this data, we're going to pipe it into our model, and the model is going to have a few different things, but it'll take in an image of the screenshot, and it'll take in all of the tokenized information. And it's going to try to predict basically the next token. Just like any other causal model, just like any other large language model basically is trained. And so the image processor, I'm trying out Sam2. And I might also do like some other image processors that are a little bit better at encoding words, like Gemini, but Sam2, and then also within the system, we're going to have a thing that processes text better, and I'm trying out Llama 3, and so I'm going to figure out how to integrate this information such that the next token prediction works well. It's kind of non-obvious because the difficulty is, like, for any given task, tokenizing the whole task, it'll just look like it'll be like, oh, they clicked here, they moved their mouse here, they clicked here, they typed in this input. Let's say a task takes like 2 minutes to do. Maybe you're sending an email, maybe you're filling out a form. Like, roughly speaking, after you tokenize, you're going to be in the realm of about like 1,000 tokens. It'll be like 1K tokens. So this is not too many. And like basically any large language model can take an input and have an output of 1,000 tokens. It's fine. But the problem is, in that same time period, we might have, 2-minute time period. What would that be? About 1,000 images, right? Maybe not quite that, but even call it 100 images. It's going to be difficult to process those 100 images in the same way as we would process 100 tokens, just because an image is, especially if we're needing to like click on a specific part of the image, we're going to have to represent it in high resolution. In other words, it's going to take a lot of GPU memory to represent one image, or relatively a lot. Like, you can think about it as all of the tokens would be roughly equivalent to representing one image. So I need to figure out some way where we can use not just the current image, but all the past images, and probably use all the past images with lesser resolution. So some sort of probably memory mechanism. So basically every training update, we're going to not pass all of the images, but figure out how to get the information we need from the images. To me, that's kind of the confusing part. And then also, how to integrate the image information with the model, especially if we're using like a Llama 3 model, which is just works on text, basically, how to integrate that information. And there's a lot, the general approach to this is like, the general approach to this type of like automated AI system is to basically have like a parsing system, screen parsing system that parses the current screen and then it tokenizes it. Most of these systems don't worry about the like all the other like historical screenshots. They'll basically just parse the current screen and like let's say there's some buttons on the current screen and maybe some text, and it's like a form or something, right? And so maybe the system needs to fill out this form and then like click a button, click a submit button. So most of the systems currently will parse this into some sort of text. It'll be like all of the buttons, it'll be an input form. It parses this into text and it passes to it passes to like a big LLM like ChatGPT or Llama 3. And so basically it turns a screenshot into words, a screen page into words. I'm not taking this approach because I think you can do it without it if you have enough training data. It is, to me, it's like doing the parsing. To me, it seems like an unnecessary step, but it does give you some like level of understanding of what's going wrong. So maybe it's a necessary step. But if I need to do it, I'll do it. That's fine. And then it passes to Llama 3, and then Llama 3 or the LLM does the next token prediction. So yeah, figuring out how to integrate this information is a little bit tricky. Especially the screenshot information. But that's what we'll work on. So here's my current model. And I'm just getting the basics of, making sure kind of we're working generally speaking and just the very start of it. So the images are going to be the current screenshot. The tokens will be the full tokenized thing of all the tasks the user did. So, they clicked this point, they typed in this point, and in every training sample, they're going to get all of the tokens, maybe 1,000 tokens or something. And the prompt I'll work on integrating later when I get more training data, but that will be like the actual task. So the prompt would look like, complete this registration form or whatever the task is, and it could be more. But initially, I'll probably do some like basic pre-training, and it won't even have a prompt. It'll just try to recognize patterns of various tasks if I can get enough training data. Okay. So for some reason right now, the llama isn't training. And I don't know why, so I'm just gonna So I'm gonna do this. This MLP is input dimensions, hidden dimensions, output dimensions, and that too is the number of layers. So I'm just testing this to make sure we can have a training, make sure my optimizer is working, basically. Let me just... This is a weird error. I feel like it's a hardware thing. I'm gonna restart my server. Ah, it's not a hardware thing. So that's not the right vocabulary shape. Let's see. So this is where I add all the extra vocabulary. So that vocab size is wrong for some reason. Imagine not having ChatGPT. Like, how long would that have taken me to figure out? It's crazy. Okay. Um, um, Sometimes I like to set the batch size to 2 just to make sure. Um, okay. All right, so that loss is working with just a simple uh, single layer MLP. What's weird is when what I'm a little worried about is what this shape is. Oh, it's going to break. It's not going to fit in the GPU. The shape is right. I wish it could fit in the GPU. I think the problem is something's up with this. Actually, you know how I can tell? We'll do I'll put it on the GPU. see if it trains more on the CPU. It'll be slow. So it is training. It's working. 11.6, 11.0. It's changing at least. It's a general downward. Okay, it's CUDA. I'm going to try to make the model smaller. .8. Something is not working. Oh. Wait a second. Um, didn't do any of this before I was working. This is a fucking nightmare. Okay. Hmm. Let me try to have this installed too. Quantized version model. So the LoRa adapter basically just makes it so you're not training all the parameters in the model. But do not call, instead manually set. Okay. I should probably use LoRa for this, but because it might still not be able to do it. But let's see if we can train the whole damn thing. You know what? I should probably just use Laura here. I just want to see if it works. All right. It's training the whole damn thing. Well, it's working. But I think, let me just think. No, actually, let me just train the whole damn thing. Uh, hmm. Okay, let's do this. I don't like that task type, but let me just see what type of stuff we're getting here. So that's 6 million. Yeah, it'll be fine now. So it's training. All right. And then let's see, batch size of 8. See how much memory we're using. Oops, no. Ah, crap. Is that 9 gigabytes? So we could get the batch size up to 16. I do want to, one question. What does that R and alpha mean? Okay. Basically, higher, the more. I don't know the math behind it. Okay, so now we're training the LoRa. Yeah, so it's goes down. It's training. Shoot, so it's probably just memorizing this data set. Yeah, I'll be back. Testing. Oy.
How's that? Worse?
Like testing. Okay. All right. So the first thing we'll try is all right. So we're gonna pass this image encoder as a SAM2 model, segment anything 2. So I'm gonna pass this is going to be the full resolution one. I'll try to keep the batch size to 2. 3, okay. Or batch size 1. You're kidding me. Ah, I'm an idiot. Okay. Let's see if we can fit. Let's see if we can fit 2 images on here. Okay. So the image is currently batch size. It's split up into, or it has 256 dimensions times 256 times 256. So I'm just trying to think. So I'm using Sam2, the smaller version. So that would be too many. 16,000. See, what I'm debating is whether to try to pass. You have the Sam. They have the Sam model that parses an image into patches like this, and it can do it at different resolutions, but the highest resolution is 256 by 256. And each patch is 256. And so basically I'm debating whether to concatenate this and pass this directly into the LLM, But then you have 256 times 256 tokens, which is a lot. Even if I do 128 by 20, it's still 16,000. So it's a lot of tokens to be passing into the LLM. And also the other thing is like if I pass directly, let me just think. From preacher. Okay, that's exactly what I want. Good work, ChatGPT. So smart. You're just so smart. See, I don't want to pass the whole, all the image, the tokenized image to the LLM because you don't need to do all the attention across the image patches to themselves. I can just do cross attention. Um, so, you know what I might do? Uh, Also, the dimensionality is 248, which means I'd have to upscale the. CMX. Oh, there it is. D model 256. Let's see what the large is. Large. Uh, they're all 256. I'll just upscale it for now. Let's go from there. I wonder if there's a way to. Be a little more open. That's kind of what I was thinking. Okay, I'll integrate my own cross attention because I don't know what the hell this BERT thing is. Use llama compatible attention. Let me see what this is. Queries. Um, I don't. Let me just see because right. I'll try this. So I have this multi-layer cross attention that I built. ChatGPT built, really. That has layers, so it's more than. So embed to create. 4 layers is plenty of layers. Well, at least for testing. And we need to hard code this. We also want to add positional embeddings to this. And for now, we don't need. These are sinusoidal or whatever position embeddings. And then we need to reshape I'm trying to think of there's some enums, that's what I want. Rearrange, that's what I'm looking for. I like this. Okay. Makes reshaping much easier because it's very confusing without this to me anyways. So we're currently in this shape, and with this nice rearrange, just go like this. Height times width. Actually, I don't know if we just do. I think maybe we don't do that times. It's just height. And also we want it to be, see how good this is? That's how we'd want it to be, right? Okay. ChatGPT is so good, even image embeddings to Llama, and then we need to upscale the image embeddings, okay? We're going to use a simple two-layer MLP for that. Yeah, that's fine. And I'm not sure if I should do the cross-attention before passing to the Llama model or after or both. If I do it before, it could definitely mess stuff up. Because we have these input embeds that are, Llama's already been trained on it, so okay. But they should have, you know, image embeddings, image embeddings. All right, then I need to build a bigger data set and see if this is working. For now, we'll just output the logits. This will be the smallest. it's 64 by 64 resolution. All right, I think I'm going to take a break. When I come back, I'm going to build some training data. I'm going to try to just do a simple task over and over and over and over again and see if the model can learn to predict it.